So, all right, so now we're in 8.2 where we're trying to get into scheduling. That's what this whole chapter is all about. How do you schedule jobs? All right, now what is this whole thing? This is giving, it's called it's just a list of the tasks and how much time they take and the precedent tasks. So in other words, what are we talking? Let me tell you what this table means. This means job A is something that needs to be done. Maybe the if you're building a house, maybe that's the roof that needs to be done. And it's going to take 3 days, or maybe those are 3 hours, whatever. They're not telling us the units. Let's say 3 days to do this job. And then job B, maybe that's the plumbing that needs to be put in below ground. And that's going to take 11 days of work. And job C, that's going to be laying the foundation, which has to happen after the underground plumbing work. That's going to take 2 days. And what's the precedent task mean? Pre always means what? Before, right? So it must precede. It must be done beforehand. So F, here and here, F must be done before. Precedent, before B and C can be done. So you got to have F, like maybe you got to have the floors in before you start working on the walls. That makes sense. Or you got to have the plumbing in before you start working on the floors. So whatever it is, those are precedent tasks that must be done beforehand. Job D takes 5 hours and G must be done before you can start working on D. Job E takes 4 hours and C must be done before you can start working on E. Job F takes 8 days, hours, whatever. And both A and H must be done before you can work on that one, etc. All right, so get this out of the way. So then, what is the vertex set? So first off, vertex, that's just all the points, huh? A, B, C, D, E, F, G. But there's also start and there's end. We haven't brought that in before, but now we will. So in addition to all the points, all the different jobs that need to be done, there's also going to be a starting point and an ending point. So start and end, and A through H. There's our answer. That's going to be the vertex set. And then it's going to say, what is the arc set? And then in part B, it's going to ask us to actually draw the thing. So I think rather than try to answer that question about what is the arc set and try to read all those crazy letters everywhere, it'd be much better to just draw the thing. Since we have to do that in part B anyway, let's just draw the thing, and then I think these will make more sense. So I'm going to go to a fresh screen if you're okay with that, and I'm going to try to draw the thing. Get it up here for us. Okay. So I'm going to draw it. Now, this will be our first one. What I'm going to do is I'm going to produce what's called a digraph, one of those arrow diagrams, because that'll be easier. Like imagine if you were the construction manager person and you were trying to manage this job and these were the various subcontractors you had to call and schedule for when they were going to show up to work on the house, This would not be a very easy way to tell who you're supposed to call first or second. This is just a bad way of organizing the information. So that's why we're going to use the digraph. The arrows, we're going to use arrows because that's easier to look at, easier to work with. Here's how it works. So when you start doing the arrows, first off, you got to determine which points come first. Now, it's not just alphabetical or anything like that. How do you know which dots, like is it A or B? These are all dots, right? How do you know which dots are going to come right off the start?
The ones with no precedent jobs.
Well done. Good observation. Right? Any job that doesn't have anything before it must be a starter. Make sense? Good observation. So which jobs, precedent tasks, are down here? Which jobs have no precedent? This one has nothing before it, and that one has nothing before it, which means A and H. So in other words, A and H must be right off the start. The start must point to A and H. Notice you can start with job A, or you can start with job H. Either one is fine to start with because neither one has a precedent task, a task that must be done beforehand. Is that making sense on that? Neither one has something, like you couldn't say, well, I'm just gonna start with B. No. Before you can do B, you have to do F, for example, right? That's why we can't start with any of the others, because all the other jobs have some other job that must be done before them. But only A and H have no before jobs, no precedent tasks. So A and H are my starters, good job. And then from there, I would just start drawing arrows. And you can kind of clean it up later and stuff. Now, how do you draw arrows? Well, it's always the precedent points to the one above it. Precedent, so F's going to point to B, F is also going to point to C, because pre means before, huh? Pre means before. So G is going to point to D, C is going to point to E. So I'm just going to start putting it on the map. Here, let me erase it. That's the idea. So here we go. F is going to point to B. Now, I don't have F nor B on the map. That's all right. Just put down an F, point to B. We can always shift it around later if it's in a bad spot. Just going to put that arrow down. Are you tracking with me so far? And then F is also going to point to C. So I'll just say, okay, you also point to C. And then G is going to point to D. I don't have either one of those either. So I'll just put it here. I might need to move it later. G points to D. C points to E. So I have a C. C is going to point to E. That's good. Am I going too quick? And then H and A both point to F. Oh, these two. H and A both point to F. This okay? Am I confusing you? So anytime, it's always bottom points to top, and that becomes an arrow down here on my arrow diagram, my whatever it's called, diagram. Is that good so far? All right, so A has to point to F. A points to F, and H also has to point to F. Why? Because the precedent, these ones come before, so they lead to the other one. And now F points to G. F points to G. So that's a little weird. F points to G. It's okay. I mean, I don't care. You can do it however you want. But to make it easier to work with, it'd probably be nice to shift it. So I'm going to move that. So F points to G like that. It's just nice to go forward. You don't have to, though. And what did I lose? G to D. I forgot to put that one back. G to D. So I think I've got them all back. A little cleaner to look at that way. Okay, and then, no, and that's it, huh? There's no other arrows. Yeah. Is that good to there? Have to do one more thing, got to put the end on. But is everybody good to there? For starters. So what did I do? I just looked at it and said, okay, which two jobs have nothing before them? Nothing, no precedent task, nothing before them. A and H, so they came right off the start. And then I just started making arrows. F to B, C to F, just F to B, C to F, C to what? I said it backwards, huh? F to C, yeah, anyway, I'm going too quick. G to D, and I just started C to E, just put them on there. Put them all on the diagram. Now, last thing we have to put on, as I said, is the end. The end is over here on wherever you want, but basically it's on the right somewhere. Now, how do you know which arrows point to the end? Which jobs lead to the end? Basically, any dot that doesn't point away from itself. Which are the only dots that are currently ending dots? Well, this one, and this one, and this one. They will all lead to the end because there's nothing else they're pointing at. So any dot that doesn't point to anything else, then it's into the line, right? So those three will all lead to the job being wrapped up. So there we go. There's an arrow diagram. Yeah.
Why did you put the A and the H pointing to the F? Is it just because that one?
Yeah, it's because of this right here. Because A points to F and H points to F.
And you just keep going from there?
Yeah, so I just did them all that way. So the bottom always points to the top. So F points to B, and I just put an F to B pointer. And F points to C, and I put an F to C pointer, and I just built the whole thing that way. Yeah, good question. Is that making sense how I did that? It's just always bottom points to top, and I just made all the arrows that way. And then whenever dots were into the line, I pointed to the end, and there's the arrow diagram. Now that's a lot easier to work with, isn't it? You see why we do this? If you're the manager trying to set the job up, now you have a rough idea how to get going on the job, right? You're like, okay, we need to start with A. I got to call A and H. I got to get them out here first. They got to show up at the job, and after that, I got to think about calling F. They got to both get their jobs done before we can do F, and then once F goes, we can bust off onto all three of these jobs. Right? You got to flow. It just helps you see. It's better than that table up there, right? It's more useful. That's simply what we're doing. It's just a tool to help us make managerial decisions. So the arrow diagram. All right, and then so now down here, what is the arc set? The arc set, I put this answer. It's just basically listing all the arrows. Start to A, see that's an arrow, start to A. Start to H, that's an arrow, start to H. AF. Anyway, yeah. You just have to go through and find the one that has the right arrows. That's a little tedious. We good there? And then part B is basically it'll have a couple of arrow diagrams, and you pick this one, the one that looks like that. Good. So it'll be multiple choice on the real exam, whenever that is. When's our exam? A couple weeks? Something like that. Yeah, 2 weeks. All right. We good? I'll move on. Okay, 8. Can you read that stuff? It's a lot of words up there. 8 experiments need to be carried out. One of the experiments requires 10 hours to complete. 2 of the experiments require 7. Oh, it's off the screen. 2 more require 12. 3 require 20. Oh boy, it's kind of a mess. So there's a bunch of those. Okay, the 10-hour experiment cannot be started until both of the 7. Okay, stop right there. Do you see that? Both of the 7 must point to the 10. Did you catch that? That's what they're saying. The 10-hour experiment cannot be started until both the 7-hour have been completed. So the 7 lead to the 10. You got to do the 7 first, the 2 7s, and they'll lead to you being able to do the 10-hour experiment. So I'm looking to say which diagram has a couple 7s pointing at a 10. Well, I guess they both do. Right? 2 7s pointing at a 10. See the times? They're putting letters by them, A, B, C, D, whatever. That's arbitrary. They just made that up. But the numbers is what I'm focused on. See the 7 and the 7 pointing to the 10. The 7 and the 7 pointing to the 10. So far, they both look right. I'm just showing you how, bless you. I'm just showing you how you would find which answer is right. So far, they both look good. I was hoping that would seal the deal right there. It hasn't. Keep moving. What comes next? The 12-hour cannot be started until all 3 of the 20. Can you read that? All 3 of the 20 must come first. So all 3 of the 20, wait, yeah. Yeah, the 20, yeah. So all 3 of the 20 must point to the 12. They must be done, right? Is that what they said? The 12-hour cannot be started, yeah, until all 3. So the 20s are done first. 3 20s point to 12. Do we have that over here? Do we have 3 20s pointing to a 12? They're pretty small. I don't know if you can see them. I can't hardly see them. 320. Where are the 20? Okay, here's a 20. Here's a 20. And here's a 20. Are all 3 of them pointing to the 12?
They're pointing away.
They're pointing away. Here's the 12. The 12's pointing at them. That's backwards. So here it is right. The 3 20s, 1, 2, 3 20s, all pointing. See the arrows? All pointing to the 12 there. That's correct. So that's how I knew it was this answer, not the other. Actually, I just guessed and got lucky, but that's how you would really do that. Is that good? Does that make sense? How to tell? A little difference there? No, that was not right. Okay. Okay, yeah. So project is 11 tasks. Processing time in times in hours below. So what they're saying is job A takes 8 hours, job B takes 9 hours, job C takes 8 hours, etc., etc. 4 processors. Okay, now we're going to start putting people on jobs. So we're going to start some actual management. We're going to have a bunch of jobs and things that need to be done for different things, and we're going to line up workers to go do those jobs and try to do it in the most efficient way possible, not waste a bunch of employee time. So, all right, so they're saying, suppose that some kind of schedule's been made. They're not even showing us the schedule. But suppose some schedule's been made for processors. processors are workers. Let me write that for you. 4 processors means 4 workers, 4 employees working on the job. Finishing time is 29 hours. So that means 4 workers each, all, however you want to say it, work for 29 hours. So they're all out there, they all work, they all go to the job during the week and work for 29 hours. So how many total hours of work on the job is that? Whatever 4 times 29 is, huh? So that's 36, 116 hours total. Good so far? Not making sense what I'm doing? So I'm just saying 4 employees, 4 processors, and they work 29 hours. That's because that's the finishing time. Took 24 hours. What is the total idle time? That's what we're going to try to minimize. That's what we're going to try to keep as low as possible. So how do you figure that out? Idle time. Time they're not working. Time they're standing around and not working. I still remember hearing a story many years ago. It was probably 15 years ago. Anyway, but this person talked about when he was young, he used to work for some city, Santa Clarita, I don't know what city it was. Some city somewhere in California. Anyway, as a college student, he was working for the city, but he was driving a truck around, checking on job sites or something like that. But in the city setup thing, the drafters, the people that draw the plans for whatever new thing they're going to do, were behind. And so they had a lot of things to draw, and they were just behind. And so the people out driving the cars had nothing to do because bad management, because the blueprint people were behind. And so this person was told, just drive your car around the city. Don't stop it too long any one place, lest one of the taxpayers start to get the idea that you're doing nothing. And just drive around all day. After 8 hours, come on back. Because the blue, and he did that for months. And just drove his car around and came back. That's crazy, isn't it? So anyway, so that's about management, right? One group got behind the other group, and they were idle time. So that's what we're talking about here. How much idle time must have been involved? If there were 116, four employees, 29 hours to finish the job, 4 times 29, 116 total hours. This is how long each of the little jobs should have taken if everybody was working all the time and there was no wasted time. If we just add those up, so let's just add those up. So if you have a calculator, just add 8 and 9 and 8 and 5, just add them all up, because that's the total time the job should take if there's not even a wasted second at all, if it was perfect, perfect management and not even an hour wasted. 21, 26, somebody got that? 34, 40, 50, 63, 72, I think it's 80. Anybody else getting that? Anybody double checking that? Add that up, can you read that? I got 80, I can check again. 17, 25, it is 80? Okay, good, well, it must be true, 2 of us got it. 80 hours. So 80 hours is how long the job should take if it was done perfectly, with no idle time at all. They took 116 hours, right? Because four workers, 29 hours to get the whole job done. All the tasks, those are called individual tasks, 11 tasks to do the whole job. So how much time did they waste? Well, you subtract them, huh? So the idle time is 116 minus 80. That's the 36 hours wasted time. See how we're coming up with that? 4 employees at 29 hours total job time, 116 hours. The job should have only taken 80. Subtract 36 hours wasted idle time. Choose the correct answer below. So I wrote 4 processors working without any idle time would take 20 hours to complete the project. Right, 4 times 20, 80. Right, the whole job should have taken 20 hours if they all worked perfectly. 4 times 20, they would have got all 80 done. So, there we go. Is that good for starters? Does that make sense? So, idle time. Okay. This is the hard part of this chapter, so I want to go slow with you and really show you how to do this. Okay, so go ahead and put that arrow diagram on your paper. Draw that out, because we're going to use that to help us schedule the different employees to do the job. So I'll give you a second on that. And then we're going to make this little chart over here. A and B. or no, let's don't call it A, this is called 1 and 2. Yeah, processor 1 and processor 2. Like that. Draw that arrow diagram real careful on your paper. That's the main thing. We're going to use that arrow diagram a ton. Let me bring this down a little bit. Draw that arrow diagram real careful on your paper. Give you a second on that. Good. Ready to move ahead? So basically we need to start scheduling different employees to do this job. We're going to basically, we have two, they said, it's kind of off the screen now, but they said 2 processors and two employees. Sometimes they'll have us do 3, but usually 2. So basically, here's the job that needs to be done where all these different tasks, the numbers in the parentheses are how many hours the various tasks take. And you know what the arrows mean, right? Like, we have to do job A before we can do D. For example, we can't start off with D, and you get it. Okay. So, all right. So we're the manager. We're gonna have the first employee, processor 1, first employee, start working on one of those tasks. Now, which task should we have him or her start working on? Which task should we have him or her start working on? Well, which ones are options? How about that? Which ones are even possible or even allowed to be worked on? Yeah, everybody good? A, B, and C? A, B, or C can be started, yeah. So you can't start with D or E or F or G because they all have things that must be done before them, exactly. So let me write that real clear for you. I know that seems simple, but that actually, what happens is people confuse that with this priority list, and I'll explain. So you agree with me. So let me just say this statement. The arrow diagram is the main thing. Sometimes people get confused because they get kind of too focused on the priority list. So let me be real clear. The arrow diagram is the main thing. Priority list is only secondary. You first look at the arrow diagram and you say, okay, what's the arrow diagram going to allow me to do? What in this particular case? Only A, B, and C. Okay, so now if I do have options, right? I can put A or B or C for only one of them, but for processor 1, which one? When you have options, that's when you go to the priority list. You don't always have options. You'll see as we go. But I do have options right now. I could go with A. I'm the manager. I could say, hey, go start on A, or go start on B, or go start on C. Which one will I start on? Well, that's when you consult your priority list. And it'll be different, and we'll be talking about how to make a smart priority list. But for now, we're just going to blindly follow it. It says, hey, do B first. So I'll say, okay, all right, I'll do B first. So employee 1, go work on task B. B is a 5-hour task, right? So I'll have him do, so here's how you do it. You just put up here, 1, 2, just put some times up here. 1, this is 0. 1, 2, 3, 4, 5, and he's going to do job B. Just put a little time marks up at the top. That's hours that his time is going by. So processor 1, employee 1, will go work on job B, and he'll work on job B for 5 hours because that's how long task B takes. This making sense so far? And now, processor 2, employee 2, he also needs a job. So what job am I going to give him? Well, again, what jobs are available? Only A or C. So we have options. So the options for processor 2 are A or C. So go to whenever you have options, when the arrow diagram gives you choices, then you go up to your priority list. Oh, and A is preferable before C. So start with A. A is an 8-hour task. So that'll take 6, 7, 8. It'll take right to here. That's A, an 8-hour task. Good to there so far? Put a little 8 down there if it helps. 8 down there if it helps. So processor 2 takes it works for 8 hours and does tests. And to make it simple, we're not gonna like ever do part of a job or have two people work on a task. Just keep it simple, one job per person all the way to the end. No, that'd get a lot harder if we started doing other stuff. Okay, so now, next, we're the manager, and so we're sitting in the manager's office, and who is the first employee that comes back to us and says, hey, I'm done with my job, I'm ready for another job? Yeah, at 5 hours, B. B comes back at 5 hours, right? At 5 hours, B comes back and says, I'm done with my job, I finished, not B, processor 1 comes back and says, I finished task B. Okay, so what you have to do, the trick on this is you always have to put yourself in time right when you're making that decision. So right at 5 hours, what's the state of things right at 5 hours? Right at 5 hours, job B has just been completed. A is being worked on by processor 2 at that moment, but not yet done, right? At 5 hours, he won't be done till 8 hours, right? So B's done, A's being worked on. So what are the jobs, according to the arrow diagram, don't even worry about the priority list, that's secondary, just right here, focus right here. What jobs are available for processor 1 to do next? Yeah, only C. D's not available yet because A's not done. Once A's done, then D's available, right? Oh, and the other thing, you might think E's done because B is done, so you might think E's available. But whenever you have two arrows pointing, that means both these jobs must be done before you can do E. Not just one of them. That's a real important difference. Everybody catch me on that? Right? Both B and C must be done before E can be started, not just one of them. So, so the only one that we even have available is C. I'm not going to go to the priority list at all because I don't have options. There's only one task available, C. So we'll give him C. C's a 9-hour job. We're at 5 hours, so add 9, 14, right? So go to 14, 9, 10, 11, 12, 13, 14. Like that. So at 14 hours, and that's task C. Takes them up to 14 hours. Making sense so far? Glad to answer your questions. Probably other people have the same ones. Feel free to speak up. Okay. Yeah.
Okay. So you went from 5 to 8, and for C9, you went on with 14. I'm
Yeah.
confused.
Yeah. So what I'm doing, I'm just looking at processor 1. So he finished job B 5 hours because B was a 5-hour job, and then now he's going to do C, and C takes 9 hours. So 5 add 9 takes me all the way to 14. So this down here with the A, this is a whole different employee. This is employee 2, and he just does job A, which is an 8-hour job.
Okay.
He's on his own. But this is employee 1 doing job B for 5 hours, then doing job C for another 9, so he's at 14 hours now. Good. Well, I'll dial it in with how that chart, you'll get more used to these charts. Okay, now we always have to put ourselves back in time and say, okay, so what's the, you always go back to the next completed job. So what's the next job done in time? That'd be 8 hours, back here, huh? So at 8 hours, employee 2 comes to us and says, okay, I'm done, boss, I'm done with my job. And I finished A, so put yourself in time right then. Job A is done at 8 hours. So right now, A and B are done. So I keep adjusting the arrow diagram. So at 8 hours, both A and B have been finished, haven't they? A and B are done, so I'm crossing off A and B. And C, at 8 hours, at this point in time, C is being worked on by processor 1 right now, isn't it? So looking at the arrow diagram, which jobs are even available to give employee 2 a new job to work on after he's finished A? What new jobs are available for him? And D is the only one available. E's not available yet because you can't do E until both B and C are finished. And at 8 hours, C is still being worked on and won't be done until 14 hours. Is that good? So again, I'm not even going to go to my priorities. I think that's what really confuses people, is they keep thinking that they keep trying to follow that priority list too much. The priority list really is hardly ever looked at. It's really secondary. The main thing is the arrow diagram. Only when the arrow diagram gives me 2 options or maybe 3 options that I then go to my priority list. That makes sense? Most of the time, the arrow diagram just says, here's what's next. That's all you get. You know, when it does, I just do what it says. So it says D is next. D is the only job available. So I give that to processor 2, D. Now, how long is job D? It's a big one. 12 hours. We're at 8 hours. This is the second job done by processor 2. He did job A, which took 8 hours. Now he's going to do D, which is 12 hours. 8 add 12. Take him all the way to 20, won't it? 15, 16, 17, 18, 19, 20. Take him to 20 hours. Job D, we'll move it over a little more central. Job D takes him to 20 hours. Good so far? Now go back in time to the earliest, to the next completed job. So that would be here. Oops, I'm erasing things. That would be here. At 14 hours, when processor 1 comes back to the manager's office and says, okay, I'm done with job C at 14 hours. Let's be clear what's going on at that point in time. At that point in time, what's done? A, B, and C are done, aren't they? A, B, and C are done. Got to keep adjusting this arrow diagram. There we go. A, B, and C are done. And processor 2 is working on D. Okay, everybody tracking with me. See what's happening? Let's get a little confusing. At 14 hours, A, B, and C are done. A, B, and C are done. D is being worked on by the second employee. D, employee 2, processor 2 is working on D. So at this point in time, which jobs are available? Yeah, only E, huh? It's the only one, yeah. Because B and C are both done, so E's available. G's not available, you gotta get E done first. F's not available because D's not yet done, right? At 14 hours, it's the middle of D, it's not done yet. So F's not available. Yeah, so only E, again, we don't have any choices. I'm not gonna go to the priority list because the arrow diagram only gives me one option, doesn't it? So the arrow diagram says you've got to do E. E is a 6-hour job. We're at 14 hours. Add 6, right to 20 hours. Both of them are going to be done right at 20 hours. Does that make sense? Right at 20 hours. Both of them are done. So now at 20 hours, they both come back to the manager's office and say, we're done. At that point in time, both E and D are simultaneously finished. So whenever both employees come back at the same time, you always do the first one first. So first we'll do employee number 1, processor number 1. So at this point in time, what jobs are available for processor number 1? Both F and G are available, huh? Both F and, we have options now. Both F and G. So when you have options, where do you go? Now you go to the priority list. So the first one, will we do F or G first? Well, according to the priority list, F should be done before G. So he'll do F. F is a 1-hour job. That won't take him long. Just to 21 hours. Then processor 2 will do the G job, which is a 2-hour job. Take him to 22. And that last hour is idle time for the top, because there's nothing left to do, huh, at that point. So that was a pretty good schedule. That was only 1 hour wasted time. That was a very efficient. We just got lucky. We didn't really have a good plan, but it just worked out luckily. Only 1 hour of idle time. And total time, what's the total finishing time? 22 hours, right? We finished the job at 22 hours. All the jobs were finished at 20. Those are the kind of questions they're going to ask you in the multiple choice and the homework and the test and stuff. They'll say, how many hours of idle time? Or what's the total finishing time? 22 hours. Or sometimes they'll give you the 3 different things. Pick the right one, So is that good? Does that make sense on that? So sometimes we'll have big chunks of wasted time, and so we'll look for better, efficient plans. So which one was that? Let's go back. So remember that map? So it's B, C, E, F, A, D, G. Let's go back and do this one. And we'll do a bunch of these. This is pretty much what we're going to do the whole time on next Tuesday. Okay, so same thing. They want 2 processors. I skipped to number 5. Decreasing time, that's the priority. So they're not giving us letters this time. They're not saying, D before C, A before, whatever. They're not giving a priority list. Their priority list is called decreasing time, which means highest times first. Makes sense, right? You should do the biggest jobs first, get those done, and just leave the smaller jobs. Actually, it turns out, we'll see on Tuesday, that it's more than just how big the job itself is. It's how much work is behind it that really matters about what you should start on first. But we'll get to that later. So for now, they're just saying, hey, just whichever job is, if you have options, just grab the bigger job. That's what they're basically saying. Decreasing time just means if you have options, just grab the biggest job. Again, we don't do that first, huh? The arrow diagram is the first thing which tells us what to do. And secondly, we'll go to the priority list. Okay, so let's go. So processor 1, processor 2, move it down here. Processor 1, processor 2. So, we'll put our times on here. All right, can you do the first job for the first processor? Let you take the first step on that. So for processor 1, what are the options? What jobs are options? Is this the same now?
No.
Okay. Anyway, A, B, or C, right? We can start with A, B, or C. So we have options, and whenever you have options, which is usually at the beginning, you go to your priority list. So which one will we start with, A, B, or C? C, because it's the biggest time, yeah. So that's what decreasing time means. Start at the biggest and decrease. So yeah, give him C, which is a 9-hour job, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9-hour job for processor 1. And now for processor 2, the options are A or B. So which of those will we give processor 2? So we always give them the bigger time, right? So B, bigger time B on that, makes sense. So that's a 2-hour job. B, 2-hour job will come first. And who's the first person that comes back to the office and says, I'm done with my job?
B.
Yeah, the processor 2 is done with B. Right here, so you put yourself there in time. Go back to the arrow diagram. This is where you got to be careful. This is real tedious. It's easy to make a small mistake. So put yourself in time. B is done. C is still being worked on at time 2 hours, right? At time 2 hours, B just got done. C is being worked on by processor 1. And processor 2 comes to us and says, I'm ready for another job. So what jobs are available? Just A. Yeah, can't do D yet, huh? Because you can't do D till A and B are done. Because you can't do E because C's not done. So I don't even go to my priority list. Only job available is A. I don't need to consider priorities. There's only one job available. A. That takes 1 hour. Takes us up to 3 hours. Is that good so far? Let's go forward in time to 3 hours. At 3 hours, what's happening? A and B are done. C is still being worked on. What jobs are available? D is the only job available. Yeah. Again, I'm not going to my priority list. There's only one choice. So the arrow diagram rules. It's the first thing we go to. That's priority list. Right. So D is 12-hour job. So go ahead and do that. So the D is 12. So put D on there. So 12 plus 3, that'll take it to 15, won't it? 10, 11, 12, 13, 14, 15. 10, 11, 12, 13, 14, 15. Because that was add 12, right? D is a 12-hour job. Good with that? Okay, so now go back in time. What job, who's the next person that comes to our office saying they're ready for a job? Yeah, it's processor 1 at 9 hours, huh? Processor 1 comes back to the office at 9 hours, says, I'm ready for a job. What's done at that point? A, B, and C? A, B, and C are done. D's being worked on by processor 2 at time 9 hours, right? So what job is available?
E.
Only E. Again, no choices. Don't even need to mess around with priority lists. Only E is available. So going to get job E, which is an 8-hour job. So 9 add 8 is 17, huh? So 16, 17. So 17, and that is job E. 8-hour job up to 17 hours. Good to there. Who comes to the office next and says they're ready for another job? Processor 2 at 15 hours. At that point, A, B, C, and D are done. A, B, C, and D are done. E's being worked on by processor 1. So what jobs are available? Only F. You tracking with me? Only F is available. So give them F. And F is a how long job? 5-hour job. So that'll take them up to 20 hours. Kind of run out of room here. 18, 19, 20. So 20 hours. That's job F, up to 20 hours for processor 2. Who comes to the office next and they're done with the job? Processor 1 at 17 hours is done with E. And the only job available is G, 6-hour job. 17 add 6 goes to 23, doesn't it? Kind of running out of room here. 23, job G. Right, yeah, job G, 6. And there we go. So the last 3 hours, processor 2 is idle. Up to, well, that says 23 hours to 23 hours. So there we go, 3 hours of idle time, job done at 23. Does that make sense? Do you feel like you can do that?